discussed in last week. So we discussed about non-parametric methods, why we use non-parametric methods, in what kind of situations that you have to use non-parametric methods, and also we discussed the one sample sign test, right? So when you are given with the problem, how to apply the one sample sign test to test your hypothesis, and also to find the confidence intervals, and how you use the large sample approximation, right, when your sample size is larger than 50. So those things we discussed. So today I'm going to discuss another testing procedure which is known as the Wilcoxon signed rank test. So this is a bit similar to the signed rank test, but when you compare the signed rank test with the Wilcoxon signed rank test, the Wilcoxon test is more powerful than the signed rank test. So if you can remember what we did in the signed rank test, one sample sign test, so we basically count how many positive differences we have or how many negative differences we have. So we were interested about just the count, right? So we didn't use any other information. So when it comes to Wilcoxon signed rank test, what we do is, when we are given with the data set, again we check the difference between the median value and the observation. But rather than counting the number of positive differences, so counting the number of negative differences, here what we do is we observe the differences, the value of the difference of your data set, and then we rank those differences. So you can understand, we use more data, more information of your data set when you compare the sign test with the Wilcoxon signed rank test. So in that sense, actually the Wilcoxon signed rank test is more powerful since we are using more information of our data set. But the Wilcoxon signed rank test is more appropriate to use when our population is symmetric, right? So when you are having a skewed or not, if your population is not symmetric, it's always better to go with the sign test, right? So when it comes to the assumptions, it's same as the sign test. So we have some of very basic assumptions when it comes to Wilcoxon sign rank test as well. So one assumption is the sample available for the analysis is a random sample, right? It should be a random sample with unknown median value, right? Your sample should be a random sample from a population with unknown median value. And in this case, the variable of interest is measured on a continuous scale. So that is same as for the sign test. And then here another important assumption which we didn't find in sign test, that is the sampled population should be a symmetric one when we have to apply the Wilcoxon sign rank test. And same as the sign test, the scale of measurement should be at least in interval, right? And also the observations should be independent. So all the assumptions that we used in the sign test are valid for this. So we have only one additional assumption, that is the sample population should be a symmetric one. All right. So in this case, what we do is, when it comes to the hypothesis, right? When it comes to the hypothesis, we are going to test for the median value. So what you do is, so when it comes to the hypothesis, so you have H naught, where H naught, you have a null hypothesis. So in this case, I'm always using M and M naught for the median. So M is the parameter and M naught is the value that we are going to test for the median. So our hypothesis is we are going to test whether our median is equal to a given value, right? So it can be a one-sided test, it can be a two-sided test, as we explained in sign test as well. So this is the procedure. Now when it comes to the sign rank test, there is in order to calculate the test statistic, you have to do some of the calculations, right? So what you have to do first you have to take your data set, and then you have to subtract this given median value from each and every observation. Alright, so for an example, I just write it here. So if you are going to test, let's say your H note is, let's say you are going to test whether M value is equal to, let's say 4, and let's say your data set consists 1, 3, 2 and 5. So the first point that you have to do is you have to subtract 4 from each and every observation of your data set. So that is 1 minus 4, and you have 3 minus 4, 2 minus 4, 5 minus 4. Likewise, that would be your first step, right? So first you have to calculate the difference between observation and the median value, right? And then the second one. So what will happen now, if you can remember what we did in the sign test, when you are calculating the difference between the observation and the given median value, when you get a 0 difference, so I ask you to omit that observation, and then we adjust our sample size accordingly. So what will happen in this case if you get a 0 difference? What do you think? What can you do? Same thing, right? So in this case also, if you get a 0 difference, we are going to eliminate that point and reduce our sample size accordingly, right? And then what we are going to do is, then we have to rank these differences. For an example, now if I just show you the differences. So 1 minus 4, that is minus 3. Then 3 minus 4, that is minus 1. And 2 minus 4, that is minus 2. And here 5 minus 4, that is plus 1. So you have so many differences. Some are positive differences and some are negative differences, right? So what we do here is, now then we are going to rank all these differences, but actually what we are ranking is the absolute value of the differences, right? So here rank the differences from the smallest to largest without regard to their sign, right? So that is, we are taking the absolute value of these differences and then we are going to rank them. So what will happen if you have the same difference value? Now if you look at this example, you can see here you have minus 1, here you have plus 1, right? So when you take the absolute value of minus 1 and plus 1, both are the same. So how are you going to rank them? Are you going to give 1, 1 to both, or are you going to give 1 to one observation and you are going to rank the other one as 2? So that is the question. So if you have tight values, right, with the same rank position, then what you have to do is you have to just rank them as in the numerical order, and then you have to take the mean of the rank positions and put them into the tight differences, right? That is for an example. Now in this case, if you take the absolute differences, now when you take minus 3, absolute value is plus 3. When you take minus 1, absolute value is plus 1. When you take minus 2, absolute value is plus 2. When you take plus 1, absolute value is plus 1. So now you can calculate the ranks, right? So now I'm going to take the rank values, right? If you are interested in calculating the ranks, let's see. So in this case, what will happen? Now you can see the minimum number is plus 1. That is the minimum difference value when you take the absolute value of the differences. So in that case, what you have to do is you have to give here first you can give 1 to this one, and then there's another one, so I'm going to give 2. So since these two are tied observations, tied, you have a tied difference here. So what I'm going to do is I'm going to take the mean value of these two rank positions, that is 1 and 2. So how you take the mean value of 1 and 2? You take 1 plus 2 and then you have to divide by 2. So that is 1 plus 2 is 3, and when you divide by 2, that is 1.5. So rank of this observation would be 1.5 and rank of this observation also would be 1.5. And the next smallest observation is 2. So what you have to do, now we have given already 2 ranks, 1 and 2. So the next rank value is 3. So you have to give 3 for the next rank value. And the next one is 3. So you have to give, the next rank would be 4 for the ranks, right? So that's how you have to give the rank values in your observations, right? So these are the ranks. That's how you calculate the ranks in your data set. So after calculating ranks, what can you do, right? Then what you have to do is you have to obtain the summation of the ranks of the positive differences and the summation of the ranks of the negative differences. All right, so that's what you have to do, right? You have to take the summation of the ranks of the positive differences and summation of the ranks of the negative differences. Now in this case, so if when you take the summation of the ranks of the positive differences, you have to denote that as W plus. Right, so I'll just elaborate that using the same example. Now in this case, if you want to calculate W plus, right, that is the summation of the positive differences, ranks of the positive differences. Now you can see in this case you have only one positive difference, only this one. So the rank is 1.5. So in this case, W plus is 1.5. So you can just calculate W minus as well. So the W minus value is the rank of the negative differences, right? So that this is W minus. So W minus values, the summation of the ranks of the negative differences. So here you have a negative difference, rank is 4. So you have to take 4 plus. Here you have a negative difference and the rank is 1.5. So you have 1.5 plus, and then again here you have a rank, negative difference, and the rank is plus 3. So you have to take plus 3. So likewise, you take the summation of the ranks of the negative differences, which is denoted by W minus. So that is, in this case, that is equal to 8.5. So likewise, you can calculate W plus and W minus in order to calculate our test statistic. So actually, when you take W plus and W minus, there is association between W plus and W minus. So you can see this equation. So W plus is equal to n into n plus 1 over 2 minus W minus. So because of this, actually when you take W plus and W minus, right? So actually we for a given example or for a given sample, we do not expect these notations or these two values to be the same, right? But what will happen if the null hypothesis is correct? So that is, if the null hypothesis is correct, means what will happen if the median value is equal to the given median value, right? So in that case, still the W plus and W minus would be different, but there will be a small change. Right? So actually what will happen here is when you have a very small value of W plus, right, or if you have a small value of W minus, based on that we will reject our null hypothesis. So you will understand when we do our testings how we are going to do that in each case, right? So let's see how we are going to do that. So as I told you, as in the sign test, we can conduct one-sided test or we can conduct two-sided test using the Wilcoxon sign rank test. So if it is a one-sided test, you know, we can go with two alternative hypotheses. So that is, if it is a one-sided test, you can write here, there's a small typo, this should be H1. So here we can go with your alternative hypothesis can be the median value less than the given median value, right? Or else your alternative hypothesis, the H1 value, it can be median value greater than the given median value, right? So in each case you can write H naught as median equal to the given median value, or else you can just write the opposite of this. As I explained in the sign test, that would be your choice. If you like, you can write the null hypothesis here as mu greater than or equal to m greater than or equal to m naught, right? In this case, you can write the null hypothesis as m less than or equal to m naught. So that would be the same thing that we are going to test, right? So you can just write whatever whatever confident with you, you can write the null hypothesis accordingly, right? Okay, now first let's imagine now we are going to test this one. We are going to go with the one-sided test where our alternative is median is less than the given median value. So the first thing, now we have the hypothesis. So the first thing which comes to our mind is, what is the test statistic? How we are going to calculate the test statistic. So when you are given the data set, if you are going to apply the Wilcoxon sign rank test, what you have to do is, first you have to quickly calculate the differences between the observation and the median value and take the absolute value of the differences, and then what you have to do is you have to rank all the absolute values of the differences. And in this case, when it comes to test statistic, I will denote the test statistic as by W. So your test statistic is, in this case, W plus, right? That is, if you are testing less than inequality in your alternative hypothesis, here you have to go with W plus. That is an easy way to remember, right? This would be your test statistic. That is, after ranking all the absolute differences, then you have to take the summation of the ranks of the positive differences. So that would be your test statistic, right? So then the next thing, now we have calculated the test statistic. So how are we going to take our decision? What is the decision rule? So in this case, we are going to reject H naught. How? We are going to reject H naught at significance level alpha if the observed value of our test statistic, right? So that is the observed value of our test statistic. So in this case, that would be W plus, right? So this W plus is less than the tabulated or the table value, less than the table value. So this is our decision rule. We are going to reject H naught if the we are going to reject H naught under alpha level of significance if the observed value of our test statistic, so in this case that is W plus, is less than or equal, even if it is equal you have to reject, less than or equal to the table value of W for a given sample size and for a given alpha. Alright, so value I will write here for a given sample size, that is for a given n, and for a given n and for a given alpha value. Right, so how are we going to read this table value? So for that you have this Wilcoxon sign rank tables, right? So this is a Wilcoxon sign rank table, you can see. So in the first column you have the size of your sample, right? And then you can see if you are going with a one-tail test, you have to read this column. And then you have the alpha value. So in this table actually you have only two alpha values, the mostly used alpha values. We know the common values are 0.05 and 0.01. So we have only those two values in this table. So you have to refer the, let's say our sample size is 8 and alpha is 0.05. So if you are going to test a one-tail test, the corresponding value would be 5. Right, so if this table value you have to check, and then if the calculated test statistic value is less than or equal to this table value, we are going to reject H no. Right, so that's what we do when it comes to Wilcoxon sign rank test. So what will happen if you, I'll just copy this here. So if we have the one-sided test, but it's in the other way around, that is your alternative is we are going to test whether the median is greater than for a given median value. So in this case, when it comes to our test statistic, that would be W minus. That is, you have to take your sample, calculate the differences, take the absolute values, rank them, and then take the summation of the negative differences. So that would be your test statistic. So in this case, how you are going to take the decision? Right, so in this case also we are going to reject our H naught at significance level of alpha if the observed value of our test statistic, so in this case it is W minus, is less than or equal to the table value, right? Yeah, less than or equal to the table value, same as before. We are going to observe the table value from the Wilcoxon table and we are going to take the decision. Okay, so that is what you have to do if you are going with a one-sided test. So what about a two-sided test? If you are going to apply a two-sided test, how you are going to do? So we know when it comes to two-sided test, right? So your H1 would be a median, that's M equal to M naught, and H naught would be M equal to M naught, and H1 would be M not equal to M naught. Right, so in this case, how you are going to calculate the test statistic? So there is a small change, right? In this case, when you are going to calculate the test statistic, right? In this case, when you are going to calculate the test statistic, so the test statistic is denoted by W. So W is, in this case, it's the minimum of W plus and W minus. It's the minimum between W plus and W minus. Right, so you have, first you have, that is, if you are going with a two-sided test, First you have to take the sample, take the differences, absolute differences, you have to track them. In this case, you have to take the summation of all the positive ranks as well as all the negative ranks as well. Right? So when you take the minimum value out of W plus, that is the summation of all the positive ranks, the summation of the ranks of the positive differences, right? And the W minus is the summation of the ranks of all negative differences. So when you observe W plus and W minus, you have to choose the minimum value as your test statistic. Right? So what will happen when it comes to the decision rule? So when it comes to the decision rule, you have to reject H naught by observing your test statistic, by observing the calculated value of your test statistic. So in this case, I will denote it as W because we never know whether that is W plus or W minus when it comes to two-sided one. So what you have to do is you have to check your test statistic value, and if the test statistic value is less than or equal, right, to the table value, we have to reject H naught. But in this case, when you are looking for the table, since this is a two-sided one, this alpha value, the significance value, we have to divide by 2. But when you look at the table which I showed you, in this table, you have the two-tail test values and one-tail test values separately. So in that case, you don't have to divide alpha by 2 again. You have to just go to the two-tail test columns and then refer the alpha and the sample size, right? But there are some tables where you have only the one-tailed values and so many alpha values. In that case, when you are going to read a table value for a two-sided test, you have to divide your alpha value by 2, right? So actually, this is how we are going to calculate the test statistic and how we take the decision with the Wilcoxon sign rank test. Now I would like to talk some more information about this distribution of the test statistic, right? Because when it comes to the distribution of the test statistic, it's actually a special one because we all the time we refer to the, when it comes to W, we all the time refer to the rank values of the positive differences, right? So when it comes to this, so we are always giving a rank to each and every observation. So in that case, the minimum value W can take is 0. Why it's 0? So when you have a data set, if you get all positive differences, all negative differences, right, in such cases, when you take the, let's say for a given data set, you have only positive differences. So if you have only positive differences, when you calculate the W minus value, that would be equal to 0. That is, you have no negative differences. So when you take the summation of the ranks of the negative differences, that would be equal to 0. So that is the minimum value that W can take. So because of that, when you take this test statistic, so sometimes our test statistic is equal to W plus or sometimes it's equal to W minus. Anyway, the minimum value that it can take is 0. And also what we are doing here is we are taking a summation of the rank values. So if you have n number of data in your sample and we are giving the summation as 1, 2, 3, we are giving the ranks as 1, 2, 3 as in ascending order. So when you take the total of the ranks, when you have n number of values, so the total of the ranks would be n into n plus 1 over 2. So that's simple mathematics. So because of that, the maximum value that this W, this test statistic can take is n into n plus 1 over 2. So because of that, you can see this W is always in between 0 and n into n plus 1 over 2. Right? This is the summation of the ranks. So W is always in between these two. Right? And then we can show the probability mass function of this W. Right? So W is a discrete random variable where you get a particular value for W. And we can show that this is the discrete random, the probability mass function of this discrete random variable. Right? So you can just, if you look at this discrete the probability mass function of this discrete random variable W, you can see that is equal to CW over 2 to power n. So CW is the number of possible ways to assign a plus or a negative sign to the first n integers, so that the summation of the ranks with positives or negatives is equal to W. Right? So 2 to power n means when you have n number of observations, how many combinations you can write with positive or negative signs. So that's the number of combinations you can write with positive and negative signs for a given data set. Right? So when it comes to the number of ways that you can assign with a given, let's say you have 10 observations, right? So if you have 10 observations, when you check the differences, sometimes you may get 5 positives and 5 negatives, let's say 6 positives, 4 negatives. Likewise, you can get so many combinations of positive and negative. So to find out, when you take the total number of those combinations, that is equal to 2 to power n. Alright, and then again, if you have 6 positives and 4 negatives, there are so many ways that you can assign those 6 positives and 4 negatives. Let's say for the first 6 data points, you can assign 6 positives, and for the last 4 negatives. Or else for the middle 6, you are going to assign 6 positives, and for the first 2 and the last 2, you are going to assign negatives, right? Then you have again 6 positives and 4 negatives. So when you take the possible ways, the number of possible ways that you can assign these positives and negatives in order to get the summation as W. In other words, you have to get the summation as W as well. So that will give you a probability, right? From all the combinations 2 to power n, you have this much of weights to get the summation as W. So that's it. That is the probability mass function of this W. Right? So that is also one of the things that you can learn when it comes to this distribution function of probability mass function of W, right? So I think now you're clear with the Wilcoxon's assigned rank test, like how, in which cases we are going to apply and how we are going to do the calculations. But I will explain you the calculations in the next session. But I hope this is clear with you, and just go through with this, right? Then when I'm explaining you the questions, the sums, right? If you know the concept, that would be very easy when I'm explaining you the questions and the sums, right? So go through with the Wilcoxon assigned rank test and get that into your mind. So the next time I'm hoping to discuss the questions and how we are going to apply this. Thank you very much.